right, we're going live. Hopefully you guys can hear me. I'm gonna wait for a few people to get in the chat here. I know we've got people who are waiting. So I'm just gonna wait for some indication that you guys can hear me before I proceed. Hello, hello, hello. Can anyone hear me? Looks like it should be live. Okay, too low, they say. Thank you, Mandelbrot. Sorry, I should have muted the mic before I picked it up, but there we go. Let's see here. Let me increase the gain a bit. Okay, how would I sound now? Hopefully better. Boosted the gain 14 decibels, so hopefully that does the trick. Can you guys hear me better now? Looks like I should be louder. Can you guys hear me better? Cool. Perfect, they say. Great. Thank you, Christopher. All right, so we're going to get started here. So tonight we're going to be covering new images of 3I Atlas, the interstellar comet currently passing by Mars, and it has been photographed by the Mars Perseverance rover. And there have been numerous posts on social media. I've been seeing a ton of posts across Twitter about this, claiming pictures show an elongated object that they say is the comet. So we're going to cut to the chase here. I actually want to quickly summarize my findings, and then we'll get into the analysis of why I came to these conclusions, because anyone coming back to watch this video after the fact, it's going to be a TLDR, basically a breakdown for anyone who doesn't want to stick around for the whole length of this stream, but I don't want to bury the lead here. So there are a number of posts on Twitter that claim this picture that you guys see here is the comet, and that it's a strange, bright, elongated object in the navcam images. Some of the posts will show the mastcam Z images. This is from one of the mastcam, actually the mastcam Z sensor, and they're highlighting an object transiting through the field of view. So some of the posts will show this, which is, as you can see, an image sequence, multiple pictures taken in sequence. Others focus on just the navcam images, and in fact, I'll even cut to the chase here. There's been a post by Avi on these images and his analysis, and he shows a couple of images here, two different exposures or at least gain settings of the camera. I'm not sure whether they ran a longer integration on one or just increased the gain, what have you, but there are two very different brightnesses here, obviously, and he has a whole analysis of this, and it's captioned as being two versions of an image of the interstellar comet 3I Atlas obtained by the navcam camera aboard NASA's Mars Perseverance rover. Now, like I said, I'm not going to bury the lead here. I'll tell you right up front, this is not 3I Atlas at all. This caption is totally wrong. A lot of people are starting from an incorrect premise that this picture shows Comet Atlas. As I said, there's a lot of posts that show various versions of that picture. So I've got a variety of them here on Twitter that you can see, and even Avi posted 3 hours ago an analysis of these images. But this is all wrong. So what's really going on here? So I'm going to show you what that picture looks like in context. That picture from the nav cam is part of a mosaic, a multi-panel mosaic that you see here. And you see the object down here, way down here. It's at the very left side of the image. It's below the center and to the left. Okay? The comet is nowhere near this bright object. And if you look at the picture up close, let me pull up the picture up close that isn't overexposed. Okay, first of all, notice that in the raw picture, it looks like if this were supposed to be a point source, I would say this is out of focus. But this isn't a point source. This is an extended object. This is filling multiple pixels here widthwise, not just in terms of length, but widthwise. So even for a streaked point source, this would be out of focus if that were a point source, but it's not. So what is that? Well, if you come into Celestia here, and we point at the rough coordinates of the comet, as seen from Celestia at the time that that picture was taken, from that perspective on the surface of Mars, Phobos, one of Mars's moons, would be down and to the left of the position of the comet. And the field of view here is 62 degrees. Keep in mind that the nav cams are extremely wide field cameras at roughly 45 degrees per field of view. And there's multiple fields of view here, right? This is a multi-frame mosaic. And this bright object only appears in the far left column of pictures. So it's over 45 degrees from the position of the center of the mosaic. So even if the center of the mosaic was the predicted position of the comet, this object is nowhere near that, and it's down to the left of that. Well, guess what was supposed to be down and to the left of the comet? Phobos. And if I pull up the coordinates of Phobos versus the coordinates of the comet from JPL Horizons at the coordinates of the Perseverance rover on Mars at the time of this mosaic, the time it was taken, 3i Atlas should have had an azimuth of about 277 degrees, an altitude of about 63 degrees. Phobos was visible from the same site at an azimuth of 243 degrees and an altitude of 38 degrees. Quite a bit different, but keep in mind, again, the navcam images are extremely wide field. And really, this is the only thing that really stands out in the raw frames. It's just this one bright, extended object, Phobos. And it's streaking here due to the integration time of the image. So the navcam images are kind of a miss on that, right? But that's not the only picture taken by the Perseverance rover. If we go back again to the tweets, let's see here. So if we go back again to the tweets, there were also these pictures being taken by a different camera on the Perseverance rover. Well, they actually just recorded their screen, but you know, there's something else there, right? So if we come over here to these images, now the one I just showed you from Twitter, that was from the previous Sol, the previous day on Mars, but these pictures here are also from mastcam Z, and you can see some very faint streaks moving against all these dots, all these colorful pixels. So some people might be mistaken in believing that these colorful pixels that are staying fixed through this whole little animation, that these are stars and something is moving against the stars. That seems to be the impression of the tweets here that I was just pointing out, like this right here. They think this one object here, this bright star streaking through this field of view, is the comet. No, that's actually just a star. That's not the comet either. So if we look again here on these pictures taken on Sol 1643, we see a variety of streaks through the field of view against all these bright pixels. This is taken with a much higher magnification than the navcam. This is with mastcam Z at a focal length of 110 millimeters. So much more zoomed in, kind of like if I were to take my wide field refractor, a little less focal length than that, but still significantly more than the navigational camera. So this is with kind of a telephoto view of the sky, looking at just a few degrees of sky instead of a wide field of view. And even in this zoomed in fashion, looking at the raw pictures, all you're able to really see in the raw pictures are stars. The comet's in here, but you have to do a lot of processing to pull it out. It's not something that you can see just by looking at the raw frames. You have to carefully calibrate these frames and subtract all these hot pixels. All these colorful pixels here, guys, this is all hot pixels. Okay, this is actually the exact same type of sensor, the same CCD that's in my deep space camera. So when I do my deep space live streams, you'll see all these colorful pixels in the first picture I show you. Those are all the hot pixels, and then what do? I have a dark frame, so the camera closes the shutter and it takes an exposure of the same length with the shutter closed in order to record anything that's showing up when there's no light coming into the camera. And that would be hot pixels like this. So then it subtracts those hot pixels from all future pictures. So that's what I do in my live streams. But you can see here, there's even more hot pixels than what I would normally see on a given night with my camera. But that's because my camera hasn't been launched to space, flown months in deep space to Mars, and then spent years on the Martian surface. This one has. It's the exact same type of CCD. It's a Kodak KAI 2020 CM, same sensor that's in my deep space camera. But it's been spending years of its life on Mars and, on the journey to Mars as well, accumulating radiation damage over the years. So it has a lot of defective pixels. But we can subtract those and see if there's anything left, anything faint that might be a comet. So basically that's what I spent today doing, is actually calibrating these pictures and stacking them based on the orbit of the comet to see if we could see it. So first of all, I had to create a reference image of the hot pixels. So this is the dark frame that I used. Out of all of those raw frames, basically I took any values of the pixels that did not change more than 5% across two images, so that in at least two images the pixel values were within 5% of the same value. Because the noise profile, not only is it severe, but it's not even actually constant. It looks constant when you're just looking at this animation. It looks like it's pretty steady except for these streaks moving through. But when you subtract like 95% of it, it's still not even constant. There's actually a gradual shift in the noise profile, which is kind of nasty as well, because you have to deal with that. It's just so severe. So if I pull up the first attempt at calibration that I did, where I tried to calibrate these frames, you'll see like the noise profile is not even constant. So let me bring Deep Sky Stacker over here. Now you can see it's really, really noisy here, but keep in mind, keep an eye on the noise profile. It's not even constant. It's shifting over the course of the images. The overall noise profile is not even constant. And if I zoom in a little bit, maybe it's easier to see. But yeah, there's a variation over time as well. So pretty nasty to deal with. So I did another pass of calibration. Initially, what I did is I just took the minimum value across all frames to try to produce a dark frame, and that did not work. I mean, it worked, but it did not work good. It did not do a very good job. So instead, I took a broader view and simply selected all pixels that were within 5% of the same value in at least two frames. Because the stars and the comet itself move so much from frame to frame, those values are not constant. But what is constant is the noise. So this is how we create the dark frame. So now what we do is we subtract this image from all of these images, and we just take a look at what's left. Okay, so we're going to do that now. We're going to take a look at what's left after we've done that calibration process. So here are the raw calibrated frames. And you can see here there's still some hot pixels left over. My process was not perfect. There's going to be some that do change more than 5%, but maybe not much more, even let's just say 6%. They fall within the exclusion criteria that they don't get swept up in the dark frame, unfortunately. But good enough. It's way better than it was. Way, way better than it was. Again, this is original, uncalibrated. And then after I did my calibration, this is what it looks like. So, again, way better than the originals. So now we have our calibrated, at least somewhat dark frame subtracted images, but all we see right now still pretty much are the stars. We see all these streaks. So what are these? So these pictures are all about 29 seconds long, 29-second long exposures, and the mast cam of Perseverance rover is not moving during these 29-second exposures. It's fixed. It's just pointing at a point in the sky where it's expecting the comet to pass through that point. And it's taking a sequence of images. In fact, it took 20 images at just about 30 seconds apiece. That's about 10 minutes worth of pictures. But it's just 20 pictures over about 10 minutes. And then these get sent back to Earth. So it's not actually tracking the sky. It's not like a telescope. It was not designed to do this. Instead, they simply pointed the mast cam up in the sky where they expected the comet to pass through, and they simply let it pass through, streaking through. And all the stars are streaks. So we have to stack this, and we can do this one of a couple ways. One is we can simply align based on the positions of a star in the frame so that all the stars line up, so they're all overlaid on top of each other. That'll help. That'll get us close. But the comet is actually moving relative to the background stars. And now, granted, these pictures are only over a 10-minute period, but this is a hyperbolic comet moving very quickly through the solar system, and it's relatively close to Mars. So it's moving through the sky, as seen from Mars, fast enough that even in a 10-minute exposure, it will slightly streak. But it'll get us much closer to the goal. So someone on Blue Sky already did this. And yes, you're right, Christopher. We're seeing the rotation of Mars here. This is the diurnal rotation of Mars. Stars setting. So again, it's actually moving in this direction from picture to picture. And as you can see, the stars are going down towards the western horizon here. So, yes, we're actually seeing the rotation of Mars. And we can align for this by overlaying the stars on top of each other. And as I was saying, someone on Blue Sky already did this. Simeon, and I apologize if I pronounce your name wrong. I actually had a character I played in my college roommate's fan film in college named Simeon, so it's how I pronounce it. But he did that. Okay, so he's aligned the pictures relative to the stars, and you see this fuzzy spot here. And yeah, that's where the comet is projected to be. It's this faint fuzzy region right here. But it's also blurred because it is actually moving relative to the stars over the course of this 10-minute period. So what I did is I applied my own Python to it, where I aligned the images based on the predicted position of the comet. But to do that, we have to astrometrically solve these pictures. We have to know the coordinates of all the pictures. We have to know what the coordinates are in each of these pictures. I tried to run these pictures as you see them through Astrometry, through astrometry.net software that I run locally on my own Linux machine. The problem was it was having a lot of trouble, even with the calibrated versions. There's still a lot of uncorrected noise in these versions, and the stars themselves are elongated streaks. So it's having trouble locking onto that. It doesn't like trying to lock onto a streak. It's looking for stars as points, little, well-tracked points. It's not intended to look for them as streaks. So to fix this, I went through, rather painfully today, and manually masked each of the pictures like you see here. So basically I masked off the entire picture except for the tips of the streaks so that they look more like point sources for astrometry so that we can actually solve the images. So I masked them like this, and we still see the stars moving through just like you do in this time lapse. But basically all I've done is I've masked out the rest of the images except for the tips of the streaks so that we can find the coordinates of the images. So after doing all of that and then astrometrically solving them, finally I was able to then align the pictures based on the orbit of the comet in order to produce a better quality, well, I would say better quality, but really intended to produce a stacked version that is aligned on the comet itself, not just the stars. So after doing that, and doing a lot more work in terms of trying to correct for the color a bit, and cropping to just the area where the images all overlap, we get this. So now, the elongated streaks are themselves blurred because the images have been realigned on the comet, 3i Atlas. And if we zoom in, we can see the nucleus of the comet is now a more unified streak. If we go to Simeon's version, again, that's a version aligned on the stars. So if we look at this version, the stars are all very solid streaks because they're all co-aligned on the stars, but the comet is this indistinct sort of fuzzy patch, which makes sense because the comet is moving relative to the stars a little bit over this 10-minute period. So the nucleus is not super well defined. But if I align on the comet based on its orbit, we get this nice defined streak, because again, each individual exposure is still being blurred by the fact that Mars is rotating and the Perseverance rover's cameras, the camera is not tracking with the rotation of the stars because it's not a telescope. It's just pointing at the position where the comet is streaking through and hoping to catch it. And they did, they caught it. And you can see, not only can you see the streak of the nucleus passing through the field of view, but you also see this diffuse glow around it. Indeed, there is cometary activity around it. And this is something that a lot of content creators on X and other social media platforms are getting wrong because they're posting pictures of Phobos from the nav cam and claiming that this is 3i Atlas, and strangely it's not showing any cometary activity as seen from Mars. Well, that's because it's not the comet. Okay, first of all, it's streaked because, as you can see, these pictures are untracked. The camera's just pointing up in the sky, and the stars are moving over the course of time that the shutter is open, and the light is being collected, and so you end up with these streaks of whether it's a star or a moon passing through the field of view. But on top of that, the nav cam is just not sensitive enough. Okay, so after everything I did, keep in mind, I've calibrated again for all those hot pixels, and again, this is what it looked like uncalibrated. And you can't even see the comet in the uncalibrated version. So, and this is with the Z, the Mastcam Z, with a 110 millimeter lens, zoomed in. Even here, the comet's here, but you can't even see it until you calibrate the images. And once you do all the calibration and enhance the contrast, it's still this faint little glow right here. Okay, it's there, it's visible, but it's still very, very faint, even with the Mastcam Z. So there was basically never any chance that the nav cam, the much wider field of view, lower magnification nav cam, was ever going to detect it. It's just not sensitive enough. And basically all you see here is the sky and something down and to the left, which again is Phobos. And that's exactly what we expect. We expect Phobos to be down and to the left of the position of 3i Atlas as seen from Mars at that time. So yeah, that's just Phobos, and we have to come over here to see the sequence of images of the comet, because again, the comet is only really detectable to the 110 millimeter lens of Mastcam Z. So not only is it only detectable to that lens, but you have to go through the process of calibrating these pictures to remove the hot pixels, to stack the images, aligning either on at least the stars, if not the comet itself. And at the end of the day, even when you do all that, you're going to get an image that is not going to be visually appealing, let's say, but it's there. It's detectable, and I've also confirmed that that is indeed where it was predicted to be at that time. So I loaded up one of the frames astrometrically solved here so that we know the coordinates. You can see the coordinates up here for every pixel of the image, and I've had a circle placed over the predicted coordinates of the comet at the time this frame was taken. You can see where it is in relation to these two streaks here, these two bright stars here. It should be down and to the right of them, and that's exactly where we see it in the stacked version. But if you even just look at an individual frame, this frame is calibrated. We're only looking here at the green channel. This program can only look at one color channel at a time. But regardless, even if I pulled up the color version, you still wouldn't see much in the raw individual frame. You have to stack multiple frames to really draw it out of the noise. But you can see that's exactly where we see it in the stacked version, is down and slightly to the right of those two streaks. And that's exactly what we see here in the stacked version. So yes, it's there. And it's technically there even in the individual raw frames, but just barely, just barely. And you really have to go through this extensive process to pull it out. And unfortunately, none of these Twitter accounts are doing that. So that's the truth of the matter. And unfortunately, there is a lot of misinformation currently on X, especially, that I've seen. I'm sure it's elsewhere too. But today I've really been seeing it all over Twitter, of these kinds of posts about this. Again, this is Phobos. This isn't 3i Atlas. This is Phobos. This isn't 3i Atlas. This is another version, I believe, of Phobos, although it's so cropped I can't really tell the context, and if it is from that nav cam, they've rotated it here. Though that does seem like that might be the case based on the orientation of the noise in the image. This looks like it has been rotated for some reason, and they even say it's been color enhanced. But this is clearly not the comet. That's something way, way brighter than the comet. And sadly, even Avi Loeb's article here 3 hours ago gets this completely wrong, labeling this as two versions of the image of the interstellar object 3i Atlas obtained by the NavCam camera aboard NASA's Mars Perseverance rover on October 4th, 2025. No, that is not 3i Atlas at all. That is Phobos from a mosaic of many images that were taken by the NavCam. And it's way off on the left of that. It's nowhere near the predicted position of the comet, and it's way, way brighter than the comet. So this is all completely false. Yeah, it's really unfortunate, and I've been, attempting to write a few community notes here and there, but there's just mass chaos, and unfortunately people are falling for it in large part. I hope the truth gets out there. I think even Avi has now since posted and updated recently. Let's see. I thought he did something. Oh, maybe not. It looks like that's the latest. No, okay, so... Okay, this is amazing to me. So I just looked at his Medium page, and there's an earlier article from a day ago where he showed Simeon's stacked photo from the previous day, I believe. And so, yeah, you can see where 3i Atlas is. You can see how faint it is relative to these stars. So he is aware of Simeon's Blue Sky page, which covered this. But he apparently still believed, as of 3 hours ago, that the super bright object on the NavCam was also 3i Atlas. It's clearly not. Like, if you just look at this is mast cam Z, and that's 3i Atlas. And even the one from a day before, I believe this is overlaid also with the planetarium program to show the predicted position. Not sure where that is on his Blue Sky. Here we go. Yeah, so here's his processing. Yeah, so this is overlaid with planetarium software, which really enhances the appearance of the comet a bit. If you just look at the animation from before the overlay appears, that's where the comet is in the pictures from a day before. It's even fainter. It's even harder to see before you throw the label over it. It's just this faint little patch of noise almost. I mean, it's very, very faint. And then when you throw the planetarium software, yeah, that's where it should be. So it's right where it should be. It's lining up. You see all these other dots that appear. These are all the rendered stars from a planetarium program. And you see 3i Atlas rendered there too, on top of that noise patch. So it's there. That's where it ought to be. But it's extremely faint. It's much more visible in the pictures taken a day later that we're now talking about, the very latest ones. So again, this is Simeon's processing of it here, and so he's aligned it based on the stars, and you can clearly see there's a comet there, and sure enough, that lines up perfectly with the predicted coordinates, just like we looked at a moment ago with SAO image DS9. This is the predicted position. And then if we look at my processing of the image, let's bring that back up. So there's my processing of it. So I've got the color version here, and you can see this is now aligned on the comet instead of the stars. So the stars are all blurred by streaking because it's aligned on the comet. So we see the comet a little bit better defined, but it's still very, very faint against the noise of the image. So no, it is not something bright enough to see in the NavCam at all. Sure, Christopher. So you got a couple questions about Sat Tracker you want me to address before we end the stream? Absolutely. Be happy to do that. Where are the pictures from the high-rise camera? I have not had time to even look for that. I've spent all day doing this, processing these pictures to get ready for this stream tonight. So I have not had time to even look for pictures from high-rise. They may be out there in raw form. Of course, NASA's currently under shutdown. So NASA's not addressing any of this because they're not allowed to right now. They're shut down. Yes, the raw frames are out there, but you have to know what to do with them. And this is the big thing. I can't emphasize enough like how much time and effort it takes to do this correctly. You have to process these pictures correctly. And Simeon would tell you too, like there's a ton of hot pixels in these Mastcam Z images that have to be corrected before you can do anything with them. And it's a time-consuming process. So you do all that, and then you have to align them, you have to stack them, you have to do all this to be able to see the comet at all. It's not a straightforward process. It's not like you can just hop onto NASA and download them in and be done. If you do that, this is what you're going to see. Something like this, right? You might see some stars, you'll see a bunch of noise. You have to clean up the noise. Anything orbiting Mars is going to have cosmic ray hits too. From even if it doesn't have a ton of hot pixels, it's going to have cosmic ray hits all over the place from radiation hitting the sensor that you're going to have to deal with. So you have to consider that too. Even on the surface of Mars, you have some of that. So like this streak here, this is an example of like a cosmic ray hit. Another one here, this bright one that suddenly appears, another cosmic ray hit. And that's only going to get worse if you get out of, to the extent Mars has an atmosphere, a thin atmosphere, and half of the possible sources, or half of the possible directions of radiation hitting you effectively being blocked by the surface below you. You go up into orbit, now you've got less, you've got an increased number of possible incident angles for radiation to strike the sensor, and even more radiation to deal with. So there's a lot that has to be done to process these pictures to be able to see the comet at all. And the average person, unfortunately, the average sort of astronomy news source on Twitter tends to not do that kind of work. They tend to not put in that kind of effort. So, you know, like 3i Atlas Anomaly, Skywatch Signal, All Day Astronomy, Shining Science, etc. These guys all got it completely wrong because for what, you know, whatever reason, whatever motives you want to ascribe to it, the fact is they're not doing this level of research and this level of effort that it takes to process these pictures, to fully understand what they're posting before they post it. Because again, these guys are all saying this is supposed to be 3i Atlas. No, look at this. This is from the Navcam. This is Phobos. It's clearly like looking at that, even the compressed version of it, like that clearly looks like not a point source to me. Like immediately when I saw this, before I even did an ounce of digging on it, I looked at that with suspicion. I'm like, that either looks out of focus or that's not a star. Yeah, that's because it's Phobos. Yeah. So, have I been watching from the beginning? Yeah, I've been watching 3i Atlas for a while. I have not focused on it as heavily as perhaps I would have liked to in hindsight, but I've been looking for my own comet quite extensively. So, back in July, I took a picture of Comet Atlas through my own telescope, which, again, strangely enough, ironically enough, the same exact type of sensor that's on the Mars Perseverance rover, the KAI 2020 CM, but in a different camera body, of course. This camera body designed to be a deep space camera for use with the telescope. So you see all these streaks, again, cylinders you might call them, you know, all these big bright streaks here. These are just stars streaking by in the background, and the comet is just this little dot right here in the middle of this white circle. And so this is exactly where the comet was predicted to be based on its orbit, and I had to align these pictures based on the orbit and then stack them, average them together, or run a max stack. I can't remember what I did for this one, but it might have been an average. But in any case, put them together, stack them together to pull this out of the noise so that you see a faint dot right here of the comet, whereas all the stars are streaking by. And you also have some hot pixels too. So I was actually tracking the stars So when I align on the comet, the hot pixels get streaked. There were a couple of unsubtracted hot pixels that form a much sharper line through here. But the rest of the streaks are stars, and you have the comet. And if you look at the raw photos, excuse me, the raw exposures, before I stack them, this is what it looks like. The comet is a very, very faint signal in the middle of this white circle. The white circle is being automatically annotated onto the image based on the, excuse me, predicted coordinates of the comet. So that's where the comet should be, and there is something there in the middle of that white circle, but it looks almost like noise. It's just very, very faint. There's a little bit of glow over to the left of the image. This image is from the telescope when it was polar aligned, so the horizon is not at the bottom of the frame, but this is actually from the comet getting real low in the sky, getting close to a light dome right before it set. So that's why you see a glow start to appear at the edge of the frame. But in the middle of that circle, that actually is 3i Atlas through my telescope on July 20th. Very, very faint, very hard to detect. This is not something the average astrophotographer would even go after, certainly not for an aesthetically appeasing image, because it's just not that appealing even when you stack it. So again, when you stack it, this is what it looks like. There's something there. There's the Comet Atlas, but it's just a very faint object. Now, it did get a bit brighter after July, but I was deep, deep in the weeds of hunting for my own comet, a comet I discovered back in 2016, 414P stereo, that was swinging back into the inner solar system and actually hit perihelion just a matter of days ago in late September. And so as it was approaching, I wanted to capture it with my own equipment. I discovered it using NASA's stereo spacecraft back in 2016, while both the comet and the spacecraft were on the opposite side of the sun, much like Perseverance and 3i Atlas, ironically enough, are now. But back then, in 2016, it was Comet 414P, and it was the stereo spacecraft that I used to discover it. Now, when I discovered it, it was initially designated P2016J3 stereo, and then when it was sighted from Earth years later, on a later orbit, it was given the permanent number designation 414P. So basically, I had been hunting for that for most of the rest of the summer, trying to get on it either with an eye telescope or my own telescope. And finally, in September, I was able to capture it with my own telescope for the very first time with my 11-inch. So this picture is stacked, a few frames stacked, aligned on the stars, and because in my case, the telescope actually was tracking the rotation of the Earth and tracking the motion of the stars during these exposures, the stars are not streaked like they are in the Perseverance photos, but these frames were not aligned on the comet. So much like Simeon's version, my comet in this version is very faint and diffuse and not well defined, but there's something there, right? Something in the middle of that circle, which is where the comet was predicted to be. This, again, is my comet, not 3i Atlas. This is 414P stereo, the comet I discovered in 2016. So what I did then is, much like I just did with 3i Atlas, I aligned these frames based on the orbit of the comet so that now the stars streak, but the comet is a solid object instead. So when I did that, I got this picture instead. So now the stars are streaked, much like what people have been seeing on X and Twitter, elsewhere. You know, all these pictures of cylinders, right? Well, as you can see here, similar situation. All these stars are now elongated, and my comet is a green glow in the middle of the picture. So you can see there's 414P stereo right there in the middle of the picture as a faint green glow against all these streaking stars. So, yeah, much like 3i Atlas, my comet is not particularly photogenic. It's not some incredible comet to look at. It's very, very faint, hard to detect, hard to find. But there were a few other amateurs who've taken pictures of it in the last few weeks as well, and I've been retweeting some of them over on X as well. But very proud to be able to finally get my own picture of my comet with my own hardware instead of just the Discovery images from NASA's stereo spacecraft. And of course, because it was discovered using NASA's stereo spacecraft, that's what it's named after, not me personally. So Christopher Levick points out 1 pixel in the Mars footage is 30 meters across, so that is a big object. So yeah, in Avi's post a few hours ago, come back to this. He mentions the fact, and I'm going to take him at his word here, that the NavCam has an angular resolution of 68 arc seconds per pixel, and so that translates to a spatial scale of 12,500 kilometers at the distance of 3i Atlas from Mars, and the projected length of the stripe is therefore about 50,000 kilometers. Well, all that is predicated on the notion that that stripe is 3i Atlas, of course. In reality, it's much closer than 3i Atlas. It's Phobos orbiting Mars. So I'm not sure what that translates to in terms of spatial scale at the distance of Phobos. I would imagine it's more than 30 meters. I'm not sure if maybe Christopher's referring to something else, but it is nevertheless, let's say, 68 arc seconds. If we go back to Celestia for a second, and we click on Phobos here. So Phobos has an apparent diameter of 12 arc minutes, almost 13 arc minutes, as seen from the Perseverance rover at the time that that stripe was imaged. So if we come back to the picture from the NavCam, so this is the raw frame from the NavCam, 13 arc minutes. If we figure 68 arc seconds per pixel, that's just a little over 1 arc minute per pixel. So Phobos should be an extended object from the NavCam, if that's true, about 13 pixels across. Of course, I'm zoomed in 800% here, but yeah, I could definitely believe that's about 13 pixels across. You know, it's an extended object, but it's not a huge object. It's, you know, at zoomed out all the way out, it's, you know, like this. But yeah, I could believe that's probably about 13 pixels across. So yeah, that tracks. That absolutely tracks as being Phobos. And it looks to me, and I don't know the details of how they run the camera on the NavCam, but I'm guessing it's some sort of internal integration where it's actually doing a series of short snaps here. It looks like multiple copies of Phobos superimposed over each other as it moves through the image. So I'm guessing they probably ran an integration where the camera's like adding up multiple exposures and then transmitting the result back to Earth. And so you end up with this sort of multi-superimposed series of images of Phobos that basically elongates into this streak. But it's not as overexposed as, of course, the other version of the frame like this here, where you can't even tell there's any separation between it. But yeah, again, that's just Phobos. That's all that is. So yeah, not a comet. That is definitely not a comet. But 3i Atlas is visible in the Mastcam Z images. This is again what the raw frames look like. So if you go and download the raw frames from Mastcam Z, you'll see this with all these wonderful hot pixels. So to recap, you have to subtract the hot pixels. I created this dark frame from that sequence of images by taking all the pixels that were within 5% of the same value of each other across at least 2 images, and retained those pixels only, so that we just get the hot pixels without any of the streaking stars or the comet, then subtract that from all the images, and then we get the calibrated frames. Let's see, where's that? Here we are. The calibrated frames that look like this, where again, the comet's down here somewhere, but really hard to see. Maybe it's there, there's a little faintness, but it's really hard to see in the individual exposures, if at all. But when we stack them and then do a little contrast enhance, we get an actual visible comet right there. So aligned on the orbit of the comet, you can see not only is there now another streak over there right where it should be according to the predicted coordinates of the comet, down and slightly to the right of these 2 bright streaks here that we see here. The comet's right where it should be, and you see some cometary activity. We see that there is a coma around it. There's this diffuse glow around it. It is a comet. It's not just a solid star. It's not just a solid streak. It actually is a diffuse object. And I would even say you could kind of see perhaps some of the green color of it, but it's hard to say. It's a very, very noisy image, as you can see here. There's a lot of chroma noise, a lot of luminance noise still in the image, but I would say that maybe there's some hint of color there as well, which is pretty good to see too. So yeah, absolutely. Uh, looks like a comet, walks like a comet. I mean, I don't see any reason to believe it's not a comet. And perhaps most importantly, we see that it's exactly where it's predicted to be. Again, if we look at SAOMG DS9, this is the predicted position of the comet. So that's where the circle is being rendered, right on the predicted coordinates, and that's exactly where we see it in the resulting stacked frame. So yeah, it's following the expected orbit, just as we expected as astronomers. Like, it's not seeming to make any kind of active maneuvering. It's not dropping into orbit around Mars as far as we can tell. It is traveling along on its hyperbolic trajectory where it will pass out of our solar system as predicted. So with that, let me tend to the chat and see what questions we have here. So Christopher Levesque says he has a 17.5-inch Dobsonian telescope. He called it Godsonian. Love it. Even with all my sophisticated setups, it's my favorite. I bet that is a beast. And Christopher, I know you had a question about Sat Tracker too, so hit me up with that question and I'll see what I can do for you. Who named my comet? So my comet was automatically named for the spacecraft that I used to discover it. And there's another very similar example out there right now. C2025 R2, I believe I got that designation right, Swan. So Comet Swan was also discovered by an amateur astronomer, Vladimir, whose last name I forget at the moment, but it was discovered by an amateur astronomer watching the Swan instrument on the SOHO spacecraft. And because he used the Swan instrument on the SOHO spacecraft to discover that comet, it was named Comet Swan. It was not named after Vladimir. So, once again, another example of a comet discovered by an amateur astronomer, but using a NASA spacecraft. So, because a spacecraft was used, it is automatically named after the spacecraft. Similarly, Comet Atlas, for example. Atlas, obviously discovered by the Atlas Sky Survey. It doesn't matter who was operating the telescope that night or who was in charge of monitoring the image data coming down, etc. It was named after the professional telescope survey that was performing the survey, not the individual astronomer per se. Now, if you're in your backyard with your own personal telescope and you discover a comet, then yes, it will be named after you personally. But if you're not using your own equipment, if you're using some professional big observatory, or you're using publicly available image data from a NASA spacecraft like I was, then it will be named after the NASA spacecraft. And that's fine with me. I'm still happy to have discovered a comet. And I'm even happier to now have, my own photo of a comet that I discovered with my own telescope. So, yeah, there it is right there, 414p stereo. And I don't have my webcam on right now, but I'm wearing my 414p stereo shirt tonight. So Christopher says he has a Meade 14-inch LX200 GPS ACF that I want to use with ISS Tracker. Will it work with the program? Should it work? Having trouble. Good question. So theoretically it should, but I do know that there are some issues with the ACF, with the AutoStar versions of LX200 with my software. The AutoStar versions of LX200 do allow you to directly set drive rates in theory, whereas the old LX200 Classic did not and had to use a workaround. Now, I did years ago implement the usage of direct drive rate control functionality using the AutoStar command set, but in playing with it, it seemed to me like it was not incorporating any slew rates past the decimal point. So, as an example, it would take in any data I fed it to tell the telescope to move at a certain speed, only in whole number integers of degrees per second, which is not great. So, for example, if I tell the telescope, I want you to move at 0.756 degrees per second, it'll just round up and do 1 degree per second, which is not good. And then it goes too fast, and then it says, oh, that's too fast. So then it drops down to like 0 degrees per second and stops for a second and then jerks back. You see my point? Like it wants to like jerk. It oscillates between too fast, too slow, because it doesn't seem to integrate the full fractional degrees per second that I'm trying to command it to do. And I'm not sure why that is. Unfortunately, Meade is now out of business. They are not only bankrupt, all their remaining stock is sold off too. So there's not going to be any help coming in terms of any official Meade support, obviously. I can try to tinker with it again, and I wonder if the AutoStar could use the LX200 Classic workaround, which is, I call it the carrot on a stick method. The classic LX200 that I have, the old Magellan computer system, would not let you directly set drive rates, meaning you could not tell the telescope, I want you to turn this many degrees per second in this direction. You could set a predefined slew rate, either full slew speed, 8 degrees per second, or finder speed, or center speed, but those were like very wide apart, different slew rates. So you could tell it to do that, but you couldn't directly set drive rates. So the workaround was what I like I said I call carrot on a stick, where I give it a go-to target a certain number of degrees away from its current position. So I find the current position of the telescope, I know where I want it to go, the direction I want it to go, I know the speed I want it to go, but I don't know how far I have to lead the target to get it there. So basically I have a virtual target that I tell the telescope to slew to, and that's my carrot at the end of a stick. And if the telescope's not moving fast enough, I have the program stick the stick out further, move the carrot out further, make the donkey go faster, telescope goes faster, until we get to the drive rate we want. So it's this iterative feedback loop where it assesses how fast the telescope's actually moving, and based on whether it's going too fast or too slow, it adjusts the stick to set the virtual point that it keeps sending the telescope to be either further away or closer to get a faster or slower tracking rate. Which is a goofy way to do things, but it works. It's a little jerky, but it works. Jerky really meaning it's sluggish. It takes it a moment to realize what it's doing and what it needs to do to get to the rate it needs to get to. But it works. I've been able to use it to track ISS for many years with my LX200 Classic. I don't know how well that technique works, if at all, with the AutoStar. I don't have an AutoStar to practice with. But if you want, I can iterate some versions for you, and we can see if we can get it working. So can we get it to move ahead and then stop for a few seconds while I get the pictures? Absolutely. We could do a leapfrog method. Yeah, that's not a problem. I can have it leapfrog ahead of where ISS is going to be, come to a stop, wait for ISS to pass through, and then leap again, and just leapfrog. We can do that. That's not a problem at all. If you're happy with that, I can definitely make my wife can make a version to do that. Got to be careful there. Yeah, there's a whole thing. I've covered it on Twitter. I don't think I've talked about it on stream, but I have responsibilities now to the VA, and the VA has very particular rules about any IP development on your own time with your own resources. Yeah, see, if I write code now, even if it's off of company time, off of company resources, and off of VA time, and off of VA resources on my own free time with my own computer that I'm currently streaming on, doesn't matter. They demand, first of all, to have the right to review that code, to decide for themselves if they should own it, even if it was made off of company time, off of company resources. And yes, I'm talking about the VA, the Veterans Affairs, Veterans Affairs, and the VA is very particular these days about IP, and it's way worse than it used to be. I have a WOC appointment with the VA, meaning without compensation. I'm not paid by the VA. Nevertheless, even as a researcher who has a WOC appointment to be able to assist with VA research, I am required to submit myself for any technological transfer that they require. So, if I were to write code under that while I am under a WOC, even if it's on my own time with my own resources, I cannot publicly release it until they've had a chance for their lawyers to look it over and decide whether they should own it or not. And they can decide that even if they decide that it was not developed on company time or resources, even if it was not developed with any VA resources at all. If they decide that because of your expertise as a researcher for the VA, if that expertise allowed you to develop that code, they now own it. That's how it works legally. So officially and for all legal purposes, I do not develop code anymore. My wife does, and my wife will post it to GitHub. So yes, basically, we can develop that, and my wife can post that to GitHub. Are there any VA in the chat? You have to tell us. Yeah. Nope, they aren't here. Yeah, hopefully not. And hey, VA, if you're watching this, you don't own anything that is posted to my GitHub going forward, because I will not be posting it. My wife will. It's her code, not mine. So my wife will be doing all future updates for Sat Tracker, Rocket Tracker, etc. Can't touch my wife. She doesn't have a VA appointment. No rush, but a couple of friends were curious about the questions I sent. All right, no problem. PXTSERYU. I'm not sure how to pronounce that. Let's see if I can find. God, this whole thing's cool. Woke Glur for using things like facts and science. Urgh. Let's see. Trying to find your questions. If you could repost them, that would help me. There's been a lot of activity in the chat. I'm sorry, I've been up on my soapbox, just rambling here. Hey, unfornicated, see you there in the chat. Appreciate you being here. Yeah, I don't see... Oh, I'm in top chat. I need to switch it to live chat. Oh, no. Let's switch it over to live chat. So will your wife get in touch with me? Well, I'll be the intermediary, I think. But yes, we'll be in touch. Questions. Do you know about Project Lyra? And do you have any similar scenarios exist for Atlas? Lyra. Is that one of those Starshot ones where they want to send a probe to another star, maybe on a laser solar light sail kind of thing? Something like that? I could be way off base. I apologize if I am. Just going off the top of my head. But are you... I'm reading between the lines a bit, but are you asking if there's any scenarios where Atlas could be an interstellar probe shot by laser or something, or some other propulsion means? They'd sling a probe around Jupiter and use a solar oberth to overshoot after Oumuamua. Oh, okay, sorry. Totally different. I was off base. I don't know. I don't know what the possible trajectories look like for an intercept with Atlas in particular. I think from what I saw Scott Manley posting that we would have kind of had to already know about it, that Atlas is so much faster than Oumuamua. Like, it's way more hyperbolic. So we would have already had to know about it, and then we could have done a flyby if we had dedicated, I think, a whole SLS to it. But we would have already had to launch it, I think. I don't know if there's a slingshot scenario that could get us to Atlas in a reasonable fashion with a reasonable amount of payload to do anything. So yeah, that's a tricky one. I know that there was a scenario that we could have possibly intercepted it as it's now flying past Mars if we launched something to go around and get ahead of it, kind of, and let it fly by. But I think it's too late for that already. So that's a great question. I will have to look into that, see if there's any remaining scenarios where we could launch something still and catch up. But I think if we did, it would have to be a ridiculously low payload fraction in order to get to enough escape velocity to get up to it. Be nice to each other, look for an email or something. Shoot me an email, Christopher. Shoot me an email over at itelescopewebcams@gmail.com. My email is in the contact information for this channel, so shoot me an email and I'll see what we can do. But we'll figure something out for you, some sort of leapfrog thing. Again, if I make an update, it'll be public, and my wife will post it to GitHub, and then we'll have a post on the channel membership page, so you'll see it. Doesn't Atlas have an eccentricity over 6? Yes, it does. So, like I was saying, I don't know that any scenarios remain that we could even catch up to it. I mean, it's way faster than Oumuamua. I don't think it's possible, to be honest, but maybe if you have some exotic solution that involves hurling a tiny solar sail and then accelerating it some more with a laser. I don't know, some exotic solution. But I don't think there's any practical solution to do it. Can I invert the black-white colors? I guess I could. Let me see. Let me pull it up in GIMP here. Colors invert. Okay, so there we go. Yeah, just close this, close this. Yeah, here we go. Let me zoom this in. There. There's a color inverted version for you. Yeah. Astronomy club I started at the high school I work at has its first observing night this Thursday. Hopefully skies clear skies that night. I hope so. That sounds awesome. Can I stack more images to get a better image? If I had more images of Atlas, then yeah. They only ran images for 10 minutes because, again, they just pointed at a single spot in the sky and then allowed the comet and the stars to streak through and ran about 29-second exposures. So keep in mind, let's go back for a second. Let me show you something else to consider here. So here are the raw images again, totally uncalibrated raw frames available from NASA. And you see the size of the frame here, kind of a 4:3 aspect ratio. And you see how much frame there is there. When I made my version, I cropped it to just the spot where all the images overlap, basically. And it looks like this. See the aspect ratio here? We're getting real thin. At some point, you wouldn't have any complete overlap of the frames. You'd have to move the camera again, which I guess they could do, but they'd have to keep doing that. They'd have to basically do a leapfrog tracking of the comet as it passes through the field of view. And I imagine there's probably limits on their data download capability, the downlink to Earth, because Mars is not in a great position. It's clear on the other side of the sun, so I don't know what those limits are right now, what that's like in terms of how much data they can fit in that pipeline back to Earth. So getting 20 full frame images down, that's I'm happy with that, put it that way. What are my thoughts about SLS as a rocket, and what are my thoughts on interstellar probe missions in general? Feasible, interesting, any other thoughts? Oh, great question. So SLS as a rocket, boy, I could soapbox on that for all night, but I will cut it short to say I'm happy that SLS has done as much as it has, which is to say it has launched once. I will tell you a little story. I was on a NASA social many, many years ago I've been on a couple NASA socials. I've been at a NASA social for the Exploration Mission 1, which was the first time they launched the Orion capsule on top of the Delta IV Heavy rocket. And a NASA social is where basically NASA would invite social media people to come out and go behind the scenes and see a launch and hear and basically have like a little mini social media press event with the principal investigators or heads of NASA centers, or even a NASA administrator himself would sometimes show up and answer questions and really get a behind-the-scenes view of what's going on at NASA. So it's really cool to be able to go out to those. And I've been to a couple. One was the first time that the Falcon 9 landed on the drone ship. I was at the NASA social for that. And that was one where they took us up on top of the VAB. So we got to go up all the way up to the roof of the VAB and look out over the whole NASA Kennedy Space Center area. And the NASA employee who was with us, who was basically our tour guide on this, talked about the various pads and the development that was going on. Falcon Heavy hadn't launched yet, but he was pointing out 39A, talking about the work that SpaceX was doing, outfitting that pad to get it ready to launch Falcon Heavy. He talked about some of the other, rockets that were still upcoming. Blue Origin was still, very early days back then. But one of the things he said was, he pointed out 39B, which is the launch pad that SLS launched from and will launch from on Artemis 2. And he talked about when Falcon Heavy was first going to launch on 39A, the projected date, whatever that was back then. And then he's like, and then from 39B, SLS will launch, well, probably never. Like, and he kind of broke out in a nervous laugh. He's like, don't post that. Don't tell anyone I said that. I mean, it was sad to see, but even this NASA employee who worked, at Kennedy Space Center, presumably in some relation to the SLS rocket, did not have high hopes for ever seeing flight. Certainly not before Falcon Heavy, and of course that much came true. And I remember Charlie Bolden, the NASA administrator at the time, making some comment about how Falcon Heavy would be nice in the future, but SLS is here now. This is a real rocket right now. We got this right now. Well, look at what really happened, right? SLS was not competing on the timeline for Falcon Heavy being operational. It's competing on the timeline for Starship being operational, which Starship was not even named Starship back then. I mean, this was years and years ago. Falcon Heavy hadn't even flown yet. So my thoughts are that SLS it's a good program to have in terms of having sort of this cost plus rocket that has the capability to send us out beyond low Earth orbit. It's, we can send the Orion capsule out beyond low Earth orbit with SLS. Great. You still need something for it to do. And back when this NASA social happened, and this, guy doing this tour group up on top of the VAB was kind of laughing about the idea that he, really wasn't confident SLS would ever fly. They were talking about the asteroid redirect mission. Remember that? That's now a dead idea. Now, thankfully, SLS, I think, has something more nationally productive to do in the sense of putting astronauts back around the moon and eventually getting us to a mission that hopefully we land astronauts on the moon again and start developing space out beyond low Earth orbit rather than just capturing an asteroid. Capturing an asteroid, though, still a useful goal, right? And it was back then. That was the absolute sure thing that SLS was going to enable us to do. So the mission has evolved, and it's been a solution in search of a problem, because back when Constellation was canceled, we lost the Altair moonlander. We lost sight of the goal of landing on the moon, and we've spent years developing SLS and Orion for billions and billions of dollars, and it's an expendable rocket, and really basically an expendable capsule. So it's tough to see the long-term future of that, but I never liked the idea of putting all your eggs in one basket. And this has been true of Commercial Crew Program. I mean, remember back in the day, Boeing was the surefire bet for Commercial Crew. SpaceX was this new upstart comer that maybe they'd have success, but Boeing, they're going to get us there first. Yeah, look at how that's gone with the Starliner program, right? Starliner has been a disaster, to be honest. Much more so than SLS and Orion. At least Artemis 1 was successful. Can't say the same of the first flight of Starliner. So you never want to put all your eggs in one basket. And yes, we are seeing the advent of commercial super heavy lift rockets like Starship, hopefully in a week, from tomorrow, October 13th, the next Starship flight hopefully sees as much success as the previous flight did, and we see a progression of the capabilities of Starship. New Glenn has had a successful flight. There's a lot of promise there too. So there are other more affordable options that will be available in the near to mid future to get us beyond low Earth orbit and get crews beyond low Earth orbit. But we're not there yet. And yeah, SLS has its problems. And Orion too. I mean, yeah, there's been a lot of talk and a lot of debate about the heat shield, right? Heat shield on Artemis 1 had more chunks lost out of it than were expected. And they've done this whole analysis now that they've determined that by not doing the skip re-entry they did on Artemis 1, they can keep the heat shield in better shape, and things will be fine. And I hope that proves true. I don't have any particular reason to believe it won't. I'm not an engineer. That's way outside my area of expertise. I know there's been talk from former astronauts like Charlie Camarda, who's a lot less confident in the safety of that. And I am not an expert enough to weigh in on who is right about that. What I can say as just a passive outside observer is that I've been around for a long time. I turn 44 tomorrow, and I was outside on my parents' front lawn watching the Challenger accident. I saw it with my own eyes. And it's this normalization of deviance that gets NASA into trouble time and time again. A lot of people don't know this, but Shuttle Atlantis was almost destroyed by heat shield damage, by heat tile damage, on one of its classified DoD missions long before Columbia happened. And there was debris that rained down from, I believe, one of the SRBs up near the nose, and it damaged a whole lot of the heat shield tiles on the underbelly of the shuttle. But because of the classified nature of the mission, they did not have the normal video downlinks that they would normally have. Hoot Gibson was in command of that mission. He and his crew saw a better view of what was going on with the robot arm than Houston could see through the encrypted feeds that they had access to, which were lower bandwidth. But Hoot was very concerned for the safety of his crew. And Mike Mullane has written about this in his book Riding Rockets. Highly recommend reading that book. And I think it was in the description of that book, he talked about that Hoot knew that if he saw the shuttle aero surfaces start to trim out an increasing drag on one of the wings, that this meant that the shuttle was gradually breaking apart, which is basically what actually ended up happening years and years later with Columbia. And that he was going to keep an eye on that needle, and he knew he'd have at least 60 seconds to give Houston a piece of his mind before they lost attitude control, and then the shuttle would break apart, just as Columbia would do in 2003. And he was going to give Houston a piece of mind what he thought of their analysis in his last moments. That's what his thought was going into that reentry, which is a horrible place to be, right? And yet they came back safe and sound. So that normalized to some extent the deviance of that level of heat shield damage that NASA thought they could get away with. And it turned out, my understanding is, one of the tiles that was almost completely broken through from the damage happened to be directly under an extra thick section of the orbiter's skin, because there was a mounting point there for an antenna. So they lucked out, and if that had not been the case, if it had been somewhere more vulnerable, they wouldn't have survived. But they did, and so NASA thought they could get away with that kind of thing, and thought that, you know, a little bit of foam shedding off the external tank was not that big a deal. And then they had this visible strike during the launch of Columbia. And yeah, it looked bad on video. Hindsight's 2020. But they thought, it's fine. We've had damage like this before. Well, wasn't so fine this time, because now it punctured a big hole in the reinforced carbon-carbon on the leading edge of the wing and allowed plasma to stream into the wing and melt it from the inside out. So, all of this to say, I am never super comfortable when I hear that NASA is normalizing unexpected results with the heat shield. I don't expect anything bad will happen on Artemis 2, and I'm sure the mission will be a complete success, and we'll see the crew back safe and sound on the ground afterwards. But I hope it doesn't stop, and I don't think it will at this time, hopefully. I hope it doesn't stop NASA on improving things, improving how they're doing things. My understanding is that the heat shield type they're using, the AV coat, I believe it is, on the Orion capsule, they can't use the same solvents that they used in the production of the heat shields for Apollo, because some of those solvents are now so environmentally unfriendly as to be illegal. So they can't do things the way they did during Apollo. and they've worked around that, but it has perhaps produced a heat shield that's not as robust as Apollo, at least the one that was used on Artemis 1, maybe. So I'm not an engineer. I'm just commenting on how I see things looking in from the outside. But I never like the idea of NASA deciding to go fly when they know something is abnormal or possibly wrong. Yet these missions take many years to prepare, and they don't have the budget they had during Apollo, and so they're doing the best they can with what they've got. And decisions were made about Orion long before we had Dragon operational. And Dragon, of course, is not designed to go to the moon and back, but could they modify a Dragon to do that? I don't know. And that's not to say I am such a SpaceX fanboy that I don't see problems with the ConOps, as it were, the concept of operations for Starship in the future. The idea of launching people on Starship without an abort system. I love Dragon because Dragon has an intact abort system, the ability to get off the rocket if it starts blowing up, whether on the pad or in flight. You don't have that with Starship, just as you didn't have it on Shuttle. And yes, Starship will be able to launch uncrewed hundreds and hundreds of times, all you want, before you ever start to put people on it, just like Falcon 9. And so the idea is you can make it so reliable that you don't have to worry about an abort system. At least that seems to be the thinking there. Don't love that. Don't love that. There's always the chance for something unexpected to happen on ascent, and you need a fast way off the vehicle. And at least as it currently stands, that doesn't seem to be the case with Starship. So I like the idea of launching people on a capsule like Dragon, where you have an intact abort capability. And then once you get into orbit, yeah, you can transfer to a bigger vehicle, maybe like Starship, that has been pre-fueled in orbit and ready to go out to the moon, Mars, whatever. So we'll see what all that goes. But that's me getting off on my soapbox. You got me there. I'm sorry. It was. Hope that answers your question about my thoughts of SLS as a rocket. Roundabout way of saying I'm glad it exists, even though it's incredibly expensive, and I don't think it has a long-term future past the advent of commercial options that will be reusable and more affordable. Once something like a Starship is, if it fully succeeds and it becomes fully reusable, then it doesn't matter that you have to refuel it a bunch to get it to go out to the moon, because you get to reuse that vehicle. So there's a potential there to then rendezvous with it in low Earth orbit using a much lighter weight rocket like a Falcon 9 and a Dragon, put your crew on and go out to the moon and back. Maybe that could be a future ConOps for an Artemis program that doesn't require SLS. We'll see. My fear is that if Artemis 2 fails during reentry, NASA gets crucified by the admin. I'm sure that would happen. And personally, I don't want to see another crew lost. I watched Challenger from my front lawn. I met Rick Husband a year before Columbia was destroyed. I don't want to see another crew get killed. Hopefully that doesn't happen. Isn't SpaceX far more reckless than NASA? I can't imagine their move fast, break things model adapting well once they start doing human flight. Well, they've been doing human flight, right? Dragon. And this is the thing that surprised a lot of people, that Dragon beat the pants off Starliner. SpaceX beat the pants off Boeing on doing human spaceflight in low Earth orbit. Now, maybe you meant, doing human flight on Starship, and I agree. I have a lot of reservations about the ConOps of putting people on Starship to launch them without an abort option. I don't have those reservations about Dragon because Dragon has in-flight abort capability. And Dragon has been incredibly reliable so far, knock on wood. They've done, both commercial and NASA crew changeover missions to ISS. They've done Axiom missions. They've done Polaris Dawn. They've done Inspiration 4. They've done Fram 2. We've had a crew on Fram 2 and really Polaris Dawn, well, not Polaris Dawn, but Inspiration 4, of commercial astronauts who have no previous astronaut experience. It's an incredible vehicle and has opened the doors for true space tourism. You know, the first human flight to polar orbit. Space Shuttle was supposed to do that from Vandenberg. Never got the chance due to the Challenger accident. Yeah, which would have been scary for its own reason. Don't maybe get up on that soapbox too. You want to talk about abort zone problems there? You know, Space Shuttle had some abort capabilities. There was an abort to orbit on a mission, which I am blanking on which mission that was. I should know that off the top of my head. But there was an abort to orbit once with Shuttle. There were abort options for, RTLS, return to the launch site, transatlantic abort, the ability, even on ISS missions, to potentially abort to airports along the eastern seaboard at various points. But launching from Vandenberg, you didn't have nearly as many abort options. If they had done that, they would have had very few intact abort options that don't involve trying to bail out over the ocean. So Dragon did it, though. Fram 2, first human spaceflight to polar orbit. I mean, that is an accomplishment that I think few people paid attention to, but it is a remarkable one, because it's one that should have been met, theoretically, by Shuttle decades ago, and it wasn't. So, yeah, RTLS requires continuous miracles interspersed by acts of God to be successful. John Young, great, yeah. I also heard, I don't know if he actually said this, but I've heard he described it as a checklist of things to do while waiting to die. So, yeah, I would not want to be on an RTLS abort, but at least in theory there was something they could try to do in that kind of situation. But of course, as we saw with Challenger, there's a lot of situations like that could occur that you don't have an opportunity to try to do anything, because you have to ride out the SRBs. You can't shut them down. Something starts to go wrong, too bad. You're along for the ride until the SRBs burn out, whether that's for good or ill. And as far as, aborts go, I mean, we could talk about SLS as well. I mean, there are risk factors there, right? Because although you have an abort tower that can get the capsule off the rocket, much like Shuttle, you can't shut those SRBs down. You're not along for the ride in that you can punch out, but those SRBs are going to keep going. So that's that's not always necessarily a controlled situation if your vehicle's coming apart. There's a lot of potential for unknown problems to occur with that kind of abort situation. With Falcon 9 and with Atlas and with Vulcan, yeah, I mean, Atlas and Vulcan do have their own little SRBs, right? But not not quite the same size of SRB as a space shuttle or an SLS. But with Falcon 9, you can shut it down at any time. And if it blows up, you can get off of it with Dragon, and you're not going to have two SRBs coming off the side chasing you. So, things to think about, right? Yeah, that sounds accurate. There's a KSP video of someone using the actual shuttle avionics program to simulate a 3EO abort 15 seconds into flight. I was watching those. Yeah, I've seen those. Remarkable videos. I forget whose channel that was. I wish I could shout it out. If someone's got it in the chat, let me know. But yeah, there's remarkable videos of someone simulating various shuttle aborts using shuttle avionics in KSP, Kerbal Space Program. Thank you. Appreciate that. Yeah. I'm not going to try to pronounce that, but Dondi. Let me see if I can get the link to that. Let's see if I can link that in the chat, because that was a really good series of videos. Oh, well, okay. So there's his GitHub page. I'll link this for his GitHub project. Space shuttle system with realistic aerodynamics. For realism overhaul. Yeah, that's for KSP. Yep, there you go. There's the GitHub link if anyone wants to try that. Really cool stuff. He also did Secret Shuttle Mission 3B, which is absolutely insane. Some 007 stuff, I bet. Yeah, so somehow we got onto SLS and shuttle and all that good stuff, but all good. What other questions we got? Any comments, questions about 3i Atlas? We won't be... Oh, let me answer this. Reviews you can use asks, we won't be able to see it with the naked eye, can we? No. This was something I pointed out on Twitter, too. Somebody, one of these astronomy accounts on Twitter that doesn't always give good information, had a top 10 list of top 10 countries to see 3i Atlas naked eye. And I responded to that, quote tweeted that, and said the answer is none. 3i Atlas is not projected to reach naked eye magnitude. I very much doubt it ever will. So don't expect to see it with naked eye, or probably even really binoculars, but certainly not naked eye. I mean, you saw the pictures I took in July. Granted, it got a little brighter than that, but it was still always a telescope-only target. You know, again, this was with my 8-inch LX200 in July, and it was just barely enough telescope to detect it at all. Yeah, you hear my Chihuahua in the other room squeaking the toy. Can you perform any size estimations for 3i Atlas with this data? It's certainly beyond the quality of my data to do that with my own telescope. And the quality of Perseverance Rover, yeah, I'd have to... I mean, I suppose I could try to do some photometry with the raw images, not the processed versions here that have been contrast enhanced. But it'd be tough. It'd be real tough because, you know, these are untracked images. We don't have tracked images. It's not even tracking with the sidereal rate, the stars. It's not moving with the stars. So it's a very diffuse object, hard to accurately measure that brightness and then make an estimation on size. But based on the fact that it has been outgassing, but the trajectory doesn't seem to be showing any non-gravitational acceleration. Seems to be Sir Isaac Newton in the driver's seat for it. So, in other words, the orbit doesn't seem to be changing over time due to non-gravitational forces. Seems like gravity can fully explain the trajectory, and we see it's exactly where it's predicted to be, as seen from Mars now. That tells us that perhaps it's a relatively heavy for a comet, that it's not getting pushed around by the amount of outgassing that it's exhibited so far. So that tells us it might be fairly large for a comet. Yeah, luminosity versus distance versus pixel rate or something like that. Yeah, trying to estimate based on the luminosity and the distance, like I said, tough to do just because measuring the luminosity with this signal to noise ratio is really difficult, especially for me. Like, maybe somebody's better, more skilled at doing it, but you have to measure the luminosity of this. If you want the total brightness of the comet, for example, you have to measure the luminosity of this faint glow while subtracting the background around it. Well, where does the glow end and the background around it begin? And the background around it is not entirely homogeneous. We've got some banding in the CCDs here. You see these columns, so there's some banding there, maybe some bias that hasn't been calibrated. So very difficult to do that accurately. I wouldn't attempt it because it's too low SNR. The signal to noise ratio is too low for me. I'm sure some scientist out there will do it and do a better job calibrating these images than I have, but I spent most of today calibrating these images, and I don't really fancy spending a whole weekend doing it again. Let's see. What other questions we got? What are my links for social media if I have any besides YouTube? Yeah, I'll link my Twitter handle here at AstroFerg. If it will let me. There we go. Yeah, there's my X account. I keep calling it Twitter, but there's my Twitter account. If anyone wants to follow me there, that's principally where I post. I also have a Blue Sky, if you want to follow me there. So here's my Blue Sky account. And appreciate everyone watching and everyone hitting like and subscribe if you are enjoying the content. Is it true that probes... Is it true there was probes that came out of it and flew into Mars? No, I don't see any indication of that. I mean, the pictures that we've seen, again, this is the picture, the latest picture from the Perseverance rover of 3I Atlas. Looks like just a normal comet. These are stars. These are all known stars at that surrounding it. And if we go over to Simeon's, so again, Simeon's also annotated the whole thing, not just the comet. So you can see all these known stars and the comet there. And same for, he, processed the earlier pictures where it was even harder to detect from a previous night. And it's very, very faint. Yeah, right there. Again, these are known stars. And the comet's right there. So, very, very faint, hard to see. And then when he overlays with the planetarium software, it's annotated there, right where it should be, but very, very faint. No sign of, any probes coming out of it or anything like that going to Mars. So. Yeah, have a good one, PXT. I assume it's also impossible to know if it's tumbling. So for that, well, first of all, you really want tracked photos of it. If you had a telescope tracking it, like where you could lock onto it like this and really have a better defined photo of the comet where it's not streaked, you could do a rotational, what do they call that? Rotational asymmetry kind of processing on it, and you can tell if there's any jets coming off of it and any spiraling of those jets, which gives you some idea of the rotation of it. Some cool ways to do that. Rotational gradient, that's the term I'm trying to think of. Rotational gradient. Let me see if we can find an example picture of this. Ah, here we go. Yeah, here's an example from Hubble. I mean, extreme example here with Hubble, but here's an example. Oh, I don't want to take your survey right now. So you can see a jet rotating on Comet 252P linear here. So you can get a sense of rotation that way. Of course, this is, again, the extreme example of Hubble. We don't all have a Hubble telescope to be able to use, but even with an amateur telescope, you can do a rotational gradient and kind of get this detection of any asymmetry of dust production and outgassing. Let's see. Yeah, here's another example of rotational gradient processing. So, possible jet coming off of ISON back in the day. So, yeah, this is a rotational gradient processed image of the comet. But I can't do that with the Perseverance pictures. They're just not good enough. At least for my processing pipeline, it wouldn't work. Maybe if I tried some Richardson-Lucy deconvolution using the stars, I wonder if that would do anything. but it would take a lot of deconvolution with stars this streaked. Yeah. So I think that's about all. Any other questions, particularly about 3i Atlas? Anyone still think that the bright object on the nav cam was actually 3i Atlas? Doesn't seem like there's any dispute about that at this point. But hope I was able to clear up some misinformation here. So again, I linked in the chat my Blue Sky and Twitter accounts if you want to follow me there and stay up to date as we watch 3 Atlas go past Mars and hopefully emerge still intact on the other side of the sun later, where Earth-based telescopes will be able to get on it again. Oh, images of 3i Atlas and how the CME affected it would be great if you know any. Yeah, CME sometimes can cause tail disconnection with comets. I would say Comet Lemon right now is doing some interesting dynamic stuff. I saw Andrew McCarthy posted a fantastic photo showing what looked like a chunk coming off of it, of Comet Lemon. Let me see. Here we go. This was posted yesterday from Andrew. And you can see, oh, yeah, it's not going to let me zoom in like that. But, I mean, you can see like a chunk, looks like maybe came off there. I don't know. Some interesting dynamics going on with the tail of Comet Lemon right now, which is visible in the morning, I believe. I have not taken a photo of this comet yet. I really want to do that, especially would love to get it on film, too. I've been shooting film negatives lately. So I might try that if the weather clears up, but it's been pretty cloudy this weekend. Cloudy and occasionally rainy, even. So we'll have to see. If the weather clears up, I do want to try to get some photography of Comet Lemon. But as far as 3i Atlas goes, hard to see. You know, basically all we can see from the Perseverance photos is the nucleus and to some extent the coma around it. If it has a tail, these pictures are not high quality enough to detect it. That's not to say it necessarily completely lost its tail due to the CME. We just can't say one way or the other because the signal to noise ratio just isn't high enough, at least with the processing I've done here. Again, maybe once the shutdown ends, NASA will have a better way of processing these pictures and release their own version that's a little more cleaned up than mine. But from what I've done, I can't see a hint of a tail necessarily. Any chance of impact with Mars? No, it's going to miss Mars. It's still exactly where the orbit predicts it should be on both days that Perseverance has photographed it. Yeah, Andrew does a magnificent job with astrophotography, so go check out his stuff. He's been photographing Comet Lemon and posting some absolutely stunning pictures. So if that is it, I'm going to go ahead and wrap up this stream, and thank you all for watching. Appreciate it. Again, please subscribe for more, and I'll be hopefully doing a live stream, maybe of some of these early morning comets, like I said, if the weather improves. But until then, stay safe and clear skies.